Good evening all. You are welcome to the tutorials with from eternity, the schoolboy. Today we'll take a look at physics, and we're still on the topic scalars and what? Vectors. That is scalar quantities and what? Vector what? Quantities. In our last class, we introduced the topic. We look at the concept of scalars and scalar quantities and vector quantities. We defined the two quantities and we give examples of each of them. And we described a lot of, we describe scenarios and of two vectors acting on a particular body and what happens, what is actually the magnitude or the direction of the effective, if the vector is force, two forces acting on a particular body. So what is the direction and the magnitude, what will be the direction and the magnitude of the resultant of the two vectors? Remember, I can remember vividly, I gave us an example where I push. If I'm pushing a table from one side, one end, another person is pushing the same table on the other end, and we are pushing it in the opposite directions. If two of us apply the same force in pushing the table will do what? Will not what? Move. It will remain where it is. But if, let's assume I am at this side, Chineye that have relatively very lesser amount of strength to compare with the one I have is pushing it from the other end. And I ask a question. I want to ask three questions. Will the table move? That's number one question. If the table moves, now let's assume the force I apply is 50, for example, 50 Newton, and Chineye apply because of she's weaker than I am. She applied 5 Newton. Then, what is that? Two of us are pushing this table in the opposite direction. What will be the actual? If you agree that the table will move, which of the forces now will actually be responsible for the what? Movement of the what? The table. And when the table finally moves, what direction will it move? Will it move towards Chineye or will it move towards me? And why? So the first question, will the table move? Yes. It will move. Now, I apply a force of 50 Newton. Chineye apply 5. Minute this thing from the other side. Now, is it the force I applied or the one Chineye applied that will make the table to move? The one that I applied. Can you see? Do you agree with them? Do you agree with them? The one what? Good. The force that will make it to move is the difference of the one I applied and the one Chineye applied, because two of us are acting in the opposite what? Direction. So the table will be moved by the what? The difference of the force I applied and the force Chineye applied, and that is what we call the effective force or the resultant force or vector, as the case may be. That's the effective one. That is the resultant one that actually made the table to do what? Move. And that effective one is what? Simply what? 50 Newton from me minus 5 Newton from who? Chineye. So it's actually what? 45 what? Newton that will make the table to do what? Move. I apply 50 Newton. Chineye will counteract what I apply by 5 Newton. So the one that will make it to move is what? 45 what? Newton. Now, let's assume two of us now move the table. Two of us are in the same direction, are in the same side. Let's assume two of us are here. I'm here. Chinanya is here, and I apply my force of 50 newton, 50 newton as case may be. I apply it. Chinanya apply her small one, which is 5 newton. Now I'm here. Chinanya is here. Will the table move? Huh? Are you also aware that the table has its own issue? If the weight of the table is higher than weight of two of us, will it move? No. So let's assume that the table, the weight is less, right? We focus on me and what? Me and the Chinanya. Now, if we move it, keeping the whatever the weight or whatever constant and lower than the force we apply, if we push the table, will it move? Will it move? Now, what amount of force will make it to move? I apply 50 newton. Chinanya apply 5 newton. We add the weight of them, right? Because we are moving in the same direction. It's the force I apply plus Chinanya's force that will make the table to do what? Move. And in what the direction will it move? Towards where we are pushing it to, right? In this direction, right? Good. Thank you. That's where you now may someone ask a very important question. You know, this is when we are on the same side. May someone ask, you know, I didn't mention that one. If I'm pushing from here, Chinanya is pushing from here, and we agree that the effective force that makes it to move is what? 45 newton. What direction will it take? Will it take my direction, or will it take Chinanya's direction? If you are pushing, if it's what? Pushing. Hoping that pushing is different from pulling. If you are pushing, it will actually what? Move towards what? Chinanya. In fact, it may even climb, it may even, let me not use harsh word, it may even run over her and two of us, yes, because she cannot withstand the force. She can't withstand my strength. Oh, because so can I never say. So the thing will move like this, two of us, because the force I apply is greater than the one she's what? And the effective force or the resultant one will move, will act in her what? Direction. Is it clear? So this table will move like this. It will not move like this. Because I apply the greater what? Force. So this is basically what you see in what? Vectors. When you come to talk of addition of vector and what? Addition of what? Vector. This is basically what? This one is on a plane level. But when it's inclined, when there's an angle of inclination, then it's a different ball game. Am I communicating? That's when you start looking at parallelogram laws and what have you. When there's an angle of inclination between the two forces. This one I'm describing now. The angle between the two forces is 180 degrees. It's on a straight line. Hope you know. Because I'm moving like this, so it's on a straight line. That one, this is how you can add the vectors. This is how you can determine the resultant or the effective vector. But when there's an angle of inclination, the game changes. You have to do what? Do some resolutions, okay? Before you can, just like the one we saw the other time. The one we saw on the board the other time, where a boy tied a rope to a nail, right, on the wall. How you see how we resolve that? For even though we still do resolution of vectors anyway, but with the way we resolve it, it's clear. With the way we resolve it, it's clear that when there's an angle of inclination, then you don't follow just ordinary addition we did here. Okay? Now, so with this now, I've described everything you need to know when it comes to what? Addition of what? Vectors. When it comes to what? Addition of what? Vectors. Now look at this scenario. Look at this scenario. I said you got what you got is magnitude of the what? Displacement. True of us. You know displacement is a vector quantity, right? So you should have magnitude and what? Direction. So you have got you've got the magnitude. What is the direction now? You know the man started here, came here, and now here, right? So you need to tell us now. This magnitude now is a vector, right? So this displacement, this displacement now, this magnitude, this represents the resultant of this and this. This is what I hope you know. Now, but he got only the what? Magnitude. We want to know the direction of the man from where she started from. So, can you do that?
I don't understand. You said that you find displacement.
Displacement.
So I'm going to add this to what?
No, you have in our last class we said that displacement is a vector quantity now. So what is the direction now? No, you have to check the direction. Direction, where is the man? Remember we said something about not. Remember, find the man's direction. That's with respect to where he's. No, what you got is okay. S is 5 kilometers. That's the magnitude. You need to find the what. No. Who can solve this? Who can try? Who? Leave your 5 kilometers. You got no. You need to get the angle before you can do that. Michael has forgotten it. You need to find this angle first. If you get this angle, this man's position is, look at, with respect to where he started from, is southeast. I agree, but which angle? You know, you read from here and stop here. What angle is here? And for you to find this angle, you need to find this angle using right angle triangle. SOHCAHTOA. You find this angle. You don't subtract here from 90 to get this angle. This angle here now will give you the man's proper direction. That displacement his displacement will now be 5 kilometers south, whatever degree east. So you find this angle here first. 3 what? 53.130. Okay, 53.130. Oh yeah. Tan inverse of 4 over 3 is what? 53. Write it. So theta is now what? 53 point what? 130 degrees. Now, what do we do here now? So what next will we do? Good. You find it by doing what? Good. 90 minus 53. Good. Perfect. Do it. 90 minus 53. 130. What's the answer? What did you get? 3 what? So now you can now write the displacement where now. Displacement is now what? Write it where now. You first of all write the magnitude, then followed by the direction. Magnitude is 5 kilometers now. 5 kilometers north, sorry, south what? South. 38.6 degree what? This is the displacement of the man. This is the man's displacement. This is how to represent it as a vector. Is it clear now? Is it clear now? Good. You have contractor and this thing. You go to on Monday. Because you want to,
Like this, then this down part now, like that place.
yeah.
Where you walk southwest. And I use down part as my distance,
Yeah, what?
my opposite.
Which side?
Like, and I draw my angle here, and down there is.
Everybody, the opposite.
So I like draw my angle.
Angle.
Yes.
What are you? You can draw it, but if you get the angle, you still subtract it from 90 and get this one. Okay? Or if you like, if you get this angle, you do alternate angle. Hope you have heard of alternate angles. Now, alternate angles are equal. This angle here, angle like this. Let's assume that this is a parallel line. Two parallel lines. This angle are alternate angle. These two angles are what? Equal. So here now, if you get this one, this angle here and this angle are what? Equal. The same thing, this angle here and this one are what? Equal. So anyone you want to find, just know that once you know your alternate angle, and you can easily get what you're looking for. I will see why mathematics and physics are not separable. You will see element of so whether you are writing it in JAMB or not. If you do your mathematics well, there's no way you have issues in your JAMB physics. So there are some people that they will say, I'm not only 4 subjects. Therefore, I don't have any business with mathematics. It's not true. There are a lot of things you do in physics that you get their principle from where? Mathematics. Okay, now, there are 2 things I want to point out. I want to talk about, okay, when you're done. And I said that I will stop in by 6 p.m. so that I want, for the benefit of those that are coming from far place, especially those that I think will stop here. Can you see up here? I should continue. No, but yeah, that used to disturb that you don't come back early. Are you sure? They should not stop you from coming home. You're not serious. You are here. So why would I ask you? You are here. So now, you know what is a, you've heard of resultant vector. You've heard of component of a vector, right? Component and resultant, right? Now, if you have 2 vectors that are acting, if you have 2 vectors that are acting either in opposite direction on a body, in opposite direction or in the same direction of a body, the one that the effective force that will cause whatever change you want to cause in that body, the effective force is what we call the what? The resultant what? Force. So you have to do what? Combine them depending on the direction they are working to be able to get the effective what? Force. Just as we added when they are in the same direction, and when we subtract when they are in what? Opposite direction, to get a single force that will be effective force. That single effective force is what is called what? Resultant what? Force. That single effective force is what we call what? Resultant what? Force. Then you can also have a single force acting in a particular direction, and you'll be told to get the components of that force in different direction. We call that one component of what? The resultant what? Vector. So that means components are opposites of the what? Resultant. In resultant, you are combining two vectors, two or more vectors, or even it can be up to 5 or 6, well, acting on a body. You are combining them to get a single what? Effective what? Force. That's what you call what? Resultant. We are converging. Let me borrow the word converging. You are converging different, you know about the convergence rate now? Yeah. Different what? Forces acting in different direction to form one effective force. This particular one force is what or vector is what is called the resultant what? Vector. Now, you can also have a single vector. You resolve it and get different component of it in different what? Direction. So at your level, you have vertical, horizontal what? Component. Now, that's X and Y what? Component. Now, you have this particular single vector or this single vector can be resolved into different components. You have different what? Components. Okay? So, this mode of divergence from single to many, true of us, divergent. But this formation of resultant force is like converging, different forces or vectors coming together as single, the effective one. Just as I said, as I'm pushing this, she's pushing. Then, because the force I applied and the force she applied are acting in opposite direction. They merge together to form one single force. 50 Newton, 5 Newton will combine. It will become 50 minus 5. That resultant vector there is what? 45 Newton, one single distance. Okay? Now, that's what happens. That's what I mean by what? Resultant what? Vector and what? Component of a what? Vector, or simply put, resolution of what? Resolution of what? Vector. So vectors are a vector can be resolved into different what? Components, right? Acting in different direction. X direction or what? Y what? Direction. Of course, in this case now, you start talking of the angle of what? Inclination, okay? They can be inclined at a particular what? Angle. They can be inclined at a particular what? Angle, depending. So now it can be perpendicular. That means one may be acting like this. And one may be what? Acting like this. It can also be like this. They can be like this. Less than 90 degrees. One is acting like this, and one is what? Acting like this, okay? Okay? Then, when they are here now, this one is simple. You can easily work on this one. Where the issue lies is this one that are not at 90 degrees to each other. That's where you start applying parallelogram law. Okay? And triangular what? Law at this point. So this will form the next topic we do what? Enter. We'll look at this subtopic of what? How to get what? Resultant what? Vector. We now want to go into how to get this what? Resultant what? Vector. So you can use parallelogram method. You can also use what? You can also use what? Triangular what? Method. Triangular what? Method. And under this parallelogram, you can use calculation by simply using using a cosine rule. Have you heard of cosine rule? You can use cosine rule in of course now cosine has, you have two vectors like this, right? If they're like this, use what? Cosine what? Rule. Don't worry, by the time we get there, in our next class, I will explain that. I want us to, if you're able to come with, what is it called? Our math set, protractor, pencil, if also a plain sheet. Now we trace this thing. You will see how you can use your protractor and measure the angle. After tracing the two, we'll take an example, trace it, and measure the angle by yourself. After you measure the angle, now we'll do it by calculation using cosine rule and see whether we can get the same what? Angle, okay? And see whether what they're telling us is what? True or not. So that's why I said that we will do it practical here. We'll draw it by ourselves and measure the angles and see how far it will take us. So that will be what we will do. After the scale drawing, I will now introduce the parallelogram law, and that's where we'll take off in our next class. So I want you, if you want to appreciate this, if you go home today, get to your mathematics test. Do this now. I'm asking you now, please. If you want to appreciate these snaps, the next subtopic we are going to enter. If you want to appreciate it, I want you to go. If you go home now, read your sine, cosine rule and what? Sine rule in mathematics. Get a mathematics textbook or any material. I think maths is better. Get the textbook. Go through it. Read sine rule and what? Cosine what? Rule. So that when we now enter these things, you do what? You will do what? Appreciate it. It not look like cock and bull story for you, to you. All right. Any question? Any question? Please do your assignment. Please do the assignment. At least they said the assignment is rich. It will take you to. I'll give you the secret on how to do your assignment. If you want to do your assignment, it's not tomorrow morning. It's not 2 hours or 3 hours to lesson. You start running up and down. No. Do it when you are before you go to bed. Get your textbook, physics textbook. Open it. Look at the topic where each question is coming from. Read examples in textbook. Use it to do what? Try answering the question. If you know where the thing was gotten from past question, you can trace and see whether you can, what if the answer you got is same thing with what they got, and find out reason for any answer you are giving. All right, thank you very much for your attention. God bless you. See you on Monday. Happy Independence Day in advance.